Hello, in the last session we did multiplying surd. In this session we're going to look at dividing surd. I'm going to show you a typical example of dividing surd. So if we have root A over root B, that gives us all root A divide B. So a typical example would be root 8 over root 2. So in essence that gives us root A divided by root 2. And we can further break that down to root 8 divided by 2, which gives us root 4. And we know that root 4 is same as 2. So I'm going to give a different example. Let's say we have root 10 over root 5. So that would give us root 10 divided by root 5. So we can put them in one root, which is root 10 divided by 5, and that gives us root 2. If you have any question regarding dividing surd, you can leave them in the comment section. Okay, we're going to move on to adding and subtracting surds. Surds are added and subtracted. In other words, we can say we can sum surds the way we sum equations or expressions, and we can work them out like collecting like terms. I'll give an example of that. Let's say we have root A plus root A. That's similar to, say, x plus x, which is 2x. So it's similar like saying root A plus root A will give you 2 root A. It's like having to, because root A is unknown, it's not a whole number, so collecting 2 of them would be 2 root A. So another example would be 5 root A plus 3 root A. So 5 root A plus 3 root A. Here we have root A and a root A. What we're doing is collecting them because they are like terms. And we have 5 of these and 3 of that. So we sum them up and we're going to have 8 root A. So let's look at situations or conditions where the terms are not alike. I would say 5 root 3, for example, plus 3 root 2. In this case, we have root 3 and root 2. They are not like terms, and for that reason we cannot add them together. A typical example using linear expression is, say, 5x plus 3y. While simplifying an expression like this, there is not much we can do about it. If we're simplifying this expression, we leave our answer the way it is because there is no way we can add them up except we know the values of x and y. It's quite similar with this type of surd problems. So let's say 5 root 3 plus 3 root 2. We leave our answer like that because we cannot work it further. But in the case where we have 5 root 3 plus 2 root 2 plus root 3 minus root 2. So if we look at this, we'll find out that we have like terms. So the variables, I would say, with root 3 are 2. So we can collect them as like terms. 5 root 3, and here we have positive root 3 plus 2 root 2, take out root 2. So when we add them up, we're going to have 5. Okay, let's look at this root 3. We know that when a root stands on its own, or no number stands on its own, there is always a 1 as an integer. So here we have 5 add 1 root 3. It's just like having x. X also refers to 1x, but we don't say 1x, we just say x. Same way, this is 1 root 3. So 5 root 3 add 1 root 3, we're going to have 6 root 3. And here we have 2 root 2, take out 1 root 2, similar, and that will give us positive root 2. Because 1 root 2 take out, 2 root 2 take out 1 root 2 will give us 1 root 2. And that's what we have here. 6 root 3 plus root 2.